Hi, this is Mike Mulholland, and today we'll be looking at how to use compass bearings and trigonometry to calculate a distance. So here's what we have. We have an east-west line this many miles long, and we have a couple of compass bearings, which are angles expressed differently than we normally would in trigonometry. So a compass bearing starts with an N or an S for whether it's relative to due north or due south. And then it has a number of degrees that tells you how many degrees the actual direction deviates from true north or true south. And then it has an E or a W to tell you whether it deviates from true north or south, and true north in this case to the east, or as in this case, to the west. So we want to find the length of line BC. Since this is trigonometry, we'll be working with triangle ABC. So first we need to find these interior angles. And this angle is going to be 90 minus 54.3 or 35.7. And this is going to be 90 minus 35.7 or 54.3. Quite a coincidence that this angle equals that angle. Well, it was set up on purpose for them to add up to 90 degrees to make this easy. And since this angle and this angle add up to 90, then that one is 90, and we have a right triangle, which we need for trigonometry. So, continuing onward, this is what we now know. We know this distance, this angle, and that angle. So now how are we going to figure out this distance? It's pretty simple. There's two ways to look at it. We can look at this angle, and the sine of that angle is opposite over hypotenuse. Or we can look at this angle, which is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. But either way, it's really the same two sides. This side over that side. Sorry, this side over this side. And we know this side. So all we have to do is solve the equation. And so we end up with 0.584 times 8.68, 5.07 miles from the transmitter at C to station B, the radio direction finder at B. Now, the person who created this question set it up to be a very easy problem, but that made it also very unrealistic. Angle ACB will only be 90 degrees when the point C falls on the circle in this illustration below. An angle inscribed within a semicircle is always 90 degrees. But how realistic is it that you'd always be looking for a point on this circle? Far more likely that it would be a point inside the circle or outside the circle. How could you figure out the distance between B and C then? So let's create some right angles so we can use trigonometry. So we drop a vertical line here, and so we have this triangle, the right triangle, and this right triangle. And we know that these two add up to 8.68. So again, we want to determine the length of line BC, which I'm calling X. And so how can we do that? Let's start with the fact that both triangles have side Z in common. For BCD, this triangle, we know that the tangent of this angle is opposite over adjacent, which is Z over Y. And we also know that, and then we can solve that for Z. And then for the other triangle, we know that the tangent opposite over adjacent is Z over the other side, which is 8.68 minus y, and solve that for z. Well, so now we have two equations for z. And so we can set these two things equal, like this, and solve it for y. And so we just do the algebra to solve it for y, and eventually come up with y is 2.63. And then z, earlier we said that z was a function of y like this, and now we know y, so we plug that in here and we can calculate z. And finally, x, which is the number that we're really after. And so we know that the sine of the 40-degree angle is opposite over hypotenuse, which is z over x. And we know z, so we solve that for x, and we get 3.43. So that's the answer to the distance to the radio transmitter. Between the radio transmitter at C and the direction finder at B, which is what we were asked for. Now, just to be on the safe side, we can check that y squared plus z squared is the same value as x squared. In other words, Pythagorean theorem holds, so that helps us to feel confident that we got the right answer for what we set out to find for x, and in the process we got y and z as well. Thank you for watching.